This is the answer to Chapter 11, problem number 21 from the Smith Organic Chemistry textbook. And this problem says, draw the products formed when this acetylide ion that we're given reacts with each compound. And so we're given 6 compounds. Okay, and so the first compound here is an alkyl halide. It's a primary alkyl halide. And so this is just going to do pretty much what we would expect in this situation. And so the acetylide ion will act as a nucleophile and displace that bromine. And we will end up with these 2 carbon chains linked together. And so our product will be this. Okay, and so that's A. B is going to be exactly the same. It's a different starting material, so the product won't be exactly the same, but the reaction will be exactly the same. The acetylide ion will act as a nucleophile and displace the chlorine. And so we will get these chains just linked together. So there's our answer for B. So then for C, C is a little bit of a trick question, I guess. We've talked about this in previous problems. A tertiary alkyl halide, which is what we have in C, is going to be too sterically hindered to undergo this nucleophilic substitution reaction. And so instead, what we're going to get is elimination. And so our acetylide ion will grab a proton. So our acetylide ion will just become, well, it won't be acetylene. I guess it'll be propylene, propine. So this will be the product, or butane rather. So we'll get this from our acetylide ion, and then we will get the elimination product. So we'll get an alkene from our starting material. So we'll get this, and we will get this. So CH3CH2 2C double bond CH3. So there we go. That's the elimination product there. Moving on to the second page, looking at D. D is an alkyl halide, but it also has an alcohol in it. And so what's going to happen in D is that we will get deprotonation of that alcohol. And then the alkoxide will complex with the sodium ion. So we'll get this. And then we'll get our starting material back, but deprotonated and complexed with the sodium ion. So like this. Okay, so then E and F are epoxides. And so each of these is going to be treated with our reagent followed by water. And so our acetylide ion is going to act as a nucleophile and open the epoxide at the less substituted side. And then the water will serve to protonate our opened epoxide. And so our product for E is going to look like this. Okay, so that'll be our product for E. And then our product for F will look very similar. The only difference is we have that methyl group substituted onto the starting epoxide. And so our product is going to have to reflect that. And it will. So our product will look like this. With the alcohol here. Okay, and so that's the answer to this problem. We basically just need to know what kinds of reactions this reagent can do and how this reagent is going to be limited. For example, in part C, we had a tertiary alkyl halide. In part D, we had an alcohol, and so there's just going to be a proton exchange, and the starting material will be deprotonated and will complex with the sodium ion. And then we also, for E and F, need to know that this reagent can function as nucleophile to open epoxides. And that's the answer to chapter 11, problem number 21.